All right, back again for another video lesson. I wanted to cover right now on this session a couple last-minute topics. Go ahead and check them out, and hopefully they'll help you on the exam. One of the concepts that one of the standards near the, a month or so ago that we covered was prove that all circles are similar. There was, some different ways of doing this. We used similarity transformations to map one onto the other, to map one circle onto the other. And of course, if you can do that, we translated, then we dilated. Translate to match centers. Then dilate to match radius or size. If you can do that and then talk through it, that is one way to prove that circles are similar. And go ahead and look back in your notes. That's how we did it. At the beginning of the circles chapter was the first thing. That is one way to go. Another way to go is a lot less formal. Let's just start talking about the properties of circles. Okay. One of the main concepts that I want to discuss here is if two circles have the same radius, then the circles are congruent. Okay, that's something that we could all agree on. The reason is, what is a circle? It's all the points that are a set distance from the center. That's what defines a circle. Well, if you get two circles that have the same distance from the center, they've got to be congruent. It's not circles are not a polygon. We can't define similarity the same way we do with polygons. So this is something that we'll have to do, is we'll have to accept that. If two circles have the same radius, then the circles are congruent. If we make that statement, nobody can argue with that. And we'll continue from there. So what our goal will be is to find a way to get the two circles to have the same radius. All right. So what we'll do is, that one's pretty simple. That's congruent, though. Now, let's take a look. What if two circles have a different radius? What we want to do is now say, all right, we can still make sure that those are similar. Okay? So if two circles have different radius, or different radii, then we can show or find a scale factor that will allow us to scale up, sort of, or enlarge or reduce one the radius of one circle to match the radius of the other. So if we can, that's kind of the definition of similar, is you can scale up or scale down one figure to match the other. Okay, so that's what we're going to end up doing. We can show that there is, in fact, such a radius exists. We can find it, and it's actually pretty easy to do. All right, so take, for instance, these two circles. I want to show that they have to be similar, and we can do that right now. All clearly these are different radii, okay? So let's call the radius of circle A r sub A. The radius of circle B r sub B. Now let's say I want to, I don't know, let's say we're going to scale down circle A so that it has the same radius as circle B. Okay? So what I'll do is I'll kind of show how we do this so it can be useful in other problems as well. For me, what I like to teach my students is I always take the pre-image times the scale factor, and that gets me the size of the image, and I use that consistently. If I don't know the scale factor, I don't adjust the formula, I just leave it. What I'll do is I'll substitute whatever the pre-image is. If I don't have a scale factor, I'll call it K. I don't know why I use K, that's just what is accepted. And the image is, I want it to turn into the same as radius of B. Now again, if I'm solving for the scale factor, I'll simply apply some algebra. Okay, divide both sides by the radius of A, and there's my scale factor. Okay, so it's going to be the radius of B over the radius of A. Now I'm showing all this work, and I'm slowly gaining points. You know, I've established, I've communicated what I know, and you know, the more information that is accurate that I can give, the more points I'm earning. All right, so okay, what we can do is we're gonna continue with this. All right. So let's multiply the radius of A, of circle A, r of A, by the scale factor, and this is what we're going to show right here, r of B over r of A. Okay. This will give us an image of circle A whose radius is equal to the radius of B. Circle B. All right. Now, since we can use a similarity transformation, to sort of match the radii of any two circles, this tells us that all circles must be similar. Now, this isn't a perfect proof, but there's no way that anybody's going to score this less than full credit. And that's really what you want. You want to communicate the ideas, right? We've communicated if two circles have the same radius, they have to be congruent. If we have two circles that have different radius, we can still use a similarity transformation, dilation in this case, or enlarge, reduce, whatever you want to call it, so that we can get the image of one figure to have the same radius as the other. That's going to guarantee us that the circles are similar for any two circles with different radii. So that's going to be enough. Again, it's not exactly how I did it in class, but it's something that you should be able to easily remember for the final, if that ever comes up. All right, another one that we talked about, and this was the day before, this was the last day of class that we went over these. I'm going to skip this because there's so many of them there, but we're gonna talk about how to construct the inscribed and circumscribed circles of any triangle. Okay. Then we can talk about the properties of angles for a quadrilateral that's inscribed in a circle. Okay, we'll go and I'll use Geometry Sketchpad to demonstrate these. It's going to be pretty tricky, but let me just list some of the things in here about inscribed and circumscribed circles of a triangle. Okay, so we want to inscribe a circle in a triangle. All right, I'm going to give you a really rough sketch here right now. Okay, so let's say I have a random triangle. What it means to inscribe a circle is it means you're going to try, and this is going to be awful, but I'm going to do the best I can here. You're going to try to make a circle that basically skims every side of the triangle. All right, so that's our goal right now, is we're going to try to find that circle. Well, there's a few steps to this. First, we have to find the center of that circle and then find the appropriate radius. Okay, now the center of that circle is the intersection of the angle bisectors, of the triangle's angle bisectors. Now, what I showed my students on this was you only have to construct two angle bisectors. Wherever they hit, those, that location is going to be the center of that inscribed circle. You don't have to draw the third one. It should automatically hit there. So what we're going to do is we're going to have to construct the angle bisectors, two of them. Find where they intersect, and that's going to be the center of that inscribed circle. Now the next part's kind of been overlooked. We haven't really done a whole lot with that. Technically what we have to do is from that location, once we find that location, we actually have to go perpendicular to the line. Okay, so the shortest distance from here to here is going to be perpendicular to this side. That's going to be another difficult part. In class, we completely skipped over that, and I don't think anybody's going to dock points for not doing it. As long as you acknowledge, we know that it's supposed to, the circle's supposed to be tangent to every side. So we got to make sure the circle must be tangent to every side. Every side of the triangle. Okay. Now the information you didn't know was, all right, technically this is called the incenter. The center of the circle is the incenter. Center of the inscribed circle. And it is equidistant from every side. Of the circle. Okay. Now if you do this, what I'm saying right now is those are all the same. Okay. So the distance from the incenter to every side should be identical. Okay. Now that's kind of why we have to construct the angle bisectors, because the definition of an angle bisector, it is the collection of all points that are equidistant from two sides. The two sides of the angle. So you're starting to get some of the connection with all the concepts. All right, we've been constructing the angle bisector, And that is the definition of it, equidistant from two sides of the angle. So for instance, you get a real life problem. Say a house is equidistant from two roads. Okay, so we'll kind of look at something like that for a second. Let's get some space though. So if you have a house that we don't know where it is, but we know it's the same distance from two roads, all right? You got two roads that intersect, right? What you would establish to get equidistant from the two roads is you would construct this angle bisector, okay? Now, sometimes when you have a situation, it won't look like it's the angle bisector, but this is. So any location on this, okay, angle bisector, we can locate the house. It's equidistant from both sides. Okay, so this would be the angle bisector, and that's kind of how it would work. All right, whatever that distance is, it's the same as it is from both roads. So that's what we would look at, type of problem we might face. Back to this, though. We want to inscribe a circle in a triangle. Construct at least two of the angle bisectors. That'll be the incenter. From there, let's draw the circle that is tangent to all three sides of your triangle. Now what's going to happen is, you might get tangent to one side, but then you might overlap a little bit on another. That's just human error. The use of those construction tools is not perfect. So we'll accept a little bit of that. So let's go over to Geometry Sketchpad, and we'll show you how to do that in that software. All right, back over here. Now we're going to construct the angle bisector of, let's go with this angle right here. Yeah, let's just put some letters on these. So we're going to construct the angle bisectors. So you guys know what I'm talking about here. We're going to label the points. Sure, looks good. All right, so let's construct the angle bisector of angle A. Now, your compass tool look different, but let me just go with this. First, I'm going to put the center of my compass tool on A, and then I'm going to open it up, and I'm going to find a radius, any radius that I want, okay, which is why I just did that. All right. Now, what I try to teach my students is right here. You don't have to draw this line, but I like to just show this to my students so they kind of get what they're doing. What they just did was, you just made an isosceles triangle right here. This right here. That technically is an isosceles triangle. Didn't want to do that. Okay, right here. This side is congruent to that side because it's radius, the radius of the same circle. Now, with this side, if we bisect that segment, okay, try to remember with an isosceles triangle, if you bisect the segment, the side that's not congruent to the other two, what you're going to do is you're going to get perpendicular. You're going to end up bisecting this angle. So watch what happens. So I'm going to kind of get rid of some of this. All right. You can't hide it all, but what I'll do is I'll make that dashed. All right. Now I want to get the perpendicular bisector of this segment. So I'm going to put my compass tool. Oops. I'm going to put my compass tool on that point. Okay. I'm going to open up the compass. And I might have to open it up a little more. Yeah, I'm going to have to. I got to make sure that I pick a radius that's more than halfway. That's perfect. Now, whatever radius I use here, I've got to come over and use that there. All right, now it's going to get a little crazy. If you see this right here, that is going to be, and let me put that as thin. Okay. That is going to be the angle bisector of angle BAC. All right. Now I'm going to have to repeat this process over here at angle C. Okay. So let's try to go back through again. I'll get rid of some of these arcs and come right back. Okay, back. I just cleaned this up a little bit so it was easier for you to see. What I'll do now is I'll go ahead and get another radius. Okay. Again, I can just pick any radius I want, so I'm going to do that over here. Okay. Now I'm going to try to get the angle bisector of, say, angle C. So I pick a radius, put my compass tool on C, and construct a circle. And, okay, I center and radius. Good. Now again, let's try to remember what happened. These 2 points, if I connect all 3 of these, right, it's going to give me another isosceles triangle, just like I did over here. Now it's a different size, right? But again, if I take an isosceles triangle and perpendicular bisect that side, that base, what I'm going to do is I'm going to end up creating the angle bisector. Okay, altitude, median, this special segment that I'm going to create serves as all of those. All right, so here goes. Again, I'm going to create just a random radius. I'm just going to pick any radius I want. Okay, I am going to construct that circle. And make sure it's big enough, it will be. Use the same radius again, put your compass tool on that one, and there you go. Again, it looks messy just like the other one did. I'll clean it up in a minute, but this point right here with C is going to establish our angle bisector again. Okay. Again, let me go clean that up. These markings, you could see like I just kind of took away some of the circles so it wasn't so messy. You've got to keep these. You can't erase them all. You got to keep some of it as work shown. So that's what we want to do. So I'll just take a pause for a second. When I come back, I'll clean this up a little bit so it's not so messy. Okay, back again. So what we have done is I have the angle bisector for angle BAC. I have the angle bisector for ACB. Those 2 angle bisectors connect right there. Now, the next part of my job, technically, I should get the perpendicular, let's say perpendicular from this point to this side. So that would take a whole nother mess of steps to do. But again, to do this the right way, which we should, I'm going to go ahead and do that. So what I'm going to do is I'm going to sketch another arc. Remember, perpendicular through a point is what I'm doing right now. Perpendicular through a point. Again, this is going to get a little bit crazy. This is a part where in class we didn't talk about this. Okay, so I'm going to establish a radius from here, and what's going to happen is construct that circle. I may have to extend this side or make a smaller circle, whatever. I'm going to just extend the side. Okay, use my straight edge. Now, what I've just done is from this point, okay, I've gotten 2 points that are the same distance. And again, that kind of creates an isosceles triangle. Here goes. This is going to get ugly too. From these 2 locations, I'm going to try to get the perpendicular bisector from those 2. Here goes. I can use any radius I want. Let's come over here. That's going to be, yeah, that should be a big enough radius. So I'm going to construct that circle. Use the same radius again. Same radius. Construct that circle. And all I've done is I've taken this to this. Oh, this is a mess. All right. It's rough. I'm going to get rid of this first. I can't get rid of it. You got to leave all this work. It's really bad right there. Okay, I got to construct that. And finally, if I connect from the center to here, that's going to get me my inscribed circle. If you can follow all that, you're amazing. That's the exact way to do it. But my last step is probably unnecessary as far as establishing this perpendicular side. I don't think anybody's going to take off if you forget that, as long as you located the center of the inscribed circle properly. Okay. Now, the next one, we'll get back over and explain the circumscribed circle, which we did in class the second to last day or last day of classes. Okay, all right, back again. We're going to now try to circumscribe a circle around a triangle. So basically what we're trying to do here is any random triangle. This is going to be tough. All right, we're going to try to find the center of the circle, and this is going to be really bad, that hits all three vertices exactly of the circle. Okay, or all three vertices of the triangle, I should say, sorry. Yes, this can be done. So what we'll do is we have to find the center of that circle. Then it's a lot easier than the incenter. Okay. Once we find the center of the circle, we can pick any vertex and we can just go through it. So it's a lot easier. Okay. This is called the circumcenter. Basically, it's the center of the circle that circumscribes the triangle. How do we do it? It is the intersection of the perpendicular bisectors of the triangle, the sides of the triangle. Okay, so basically what's going to happen is we'll get the perpendicular bisector of this side, then we'll get the perpendicular bisector of that side, and if we do it properly, those will connect right there. Of course, there is a third one probably right there. So what we're looking at is the three perpendicular bisectors, one for every side. Those three will connect right there, and that will establish the circumcenter. All right, we'll go back over to the geometry sketch pad. That one will be a little easier. All we're going to do is 2 of those. It'll be a lot easier than the inscribed circle. All right, back over onto the geometry sketch pad here. What we're going to do is we're going to get the perpendicular bisector of any 2 sides. It doesn't make any difference. Let's just go with BC and perhaps, yeah. So we'll go BC and AB. What we'll do is we'll pick any radius we feel like. Make it a little bigger. And I'm going to put the center of my compass tool there. Choose a radius and draw a circle. Now, whatever radius I choose, I have to then use the same radius around point A. Now, what I just did was these 2 locations are the same distance from A as they are from B. And if I connect those, that's the definition of the perpendicular bisector. All the points, the same distance from 2 points. So I'm going to construct that line. Now, somewhere on this line will be the circumcenter of the circle. What I'll do is I'll go find the perpendicular bisector of BC right after I clean this up a little bit for you. Okay, so make sure you leave these marks. You see I just took away the whole circle. You didn't need the entire circle. So let's go ahead and let's do the same process. Pick any radius, and it's got to be a pretty big one here. What you have to do is you have to make sure your circle is going to, you're going to have a circle with a radius that's, if we centered at B, then we center another one at C, they're going to overlap. They're going to intersect. So I chose a really big radius, okay, and I'm going to center that on B, and a little bigger than I needed to. How about right there? That's good. Now, whatever that is, use the same radius on C, construct that circle, and we're missing some of the picture here. Okay, so these 2 points, I'm going to use my straight edge, connect those. And what just happened was That's going to be messy. Let me just move that a little bit. There we go. So right there is the intersection of the two perpendicular bisectors. Okay, and if I clean this up again, I'll come back and we'll show you the last step's very simple, and you know, this construction isn't nearly as bad as the other one. So, be right back. Okay, so back here, this is the circumcenter. It's where the two perpendicular bisectors, two of the three, the other one will, of course, hit that point as well. So all I have to do to finish this off is take the center of my compass tool, put it right there, and pick any of the 3 points. I'm going to choose A. And if I construct that circle, it will hit all 3 points of the triangle. Now, if yours doesn't, it's just due to a small amount of human error. It may be, you know, as far off as this. And just admit that, all right, listen, I'm using a tool that isn't perfect, and I'm going to have some error there. So those are the couple of concepts I wanted to make sure we covered, and hopefully this will be helpful. Enjoy the video, subscribe, like the page, and good luck on the exam.